Hey everybody, so today I'm going to give a little demo of some of the tools that we made to build Septerra Core, Legacy of the Creator. Now this is a game that, compared to its competitors, had a minuscule budget and a very small team. We had less than 24 people working full-time on this game, and we only had 2 programmers. Now how are you going to build an epic RPG with that small of a team? Well, the way that we did it was we built a very robust tool set. Rather than have all of the content that goes into the game need to go through the bottleneck of a couple programmers, we made this tool so that we could put all of the power, the ability to create scenes, script enemy AI, script game logic, everything into the hands of the artists and designers. That would allow the programmers to focus on things like making the game engine run really awesome and bug fixing and all that kind of stuff, and let us, the artists and designers, really concentrate on making the best content that we could. So let's take a look at the tool we built. We called it Terra Builder, and it's stuffed full of features. Right here, right in the beginning of the program, when you open it up, you have all of the levels in the game. You can open up any one of those individual levels. So this is Junker's HQ. It should be familiar to anybody who's played the game. It's kind of your main character's starting point in the game, and your sort of central hub for the beginning chapters of the game. So these levels were built in here. They were built in layers. So on the left here, we can turn on and off layers to see all of the different things that the artists built and the layout artists put into the game. And all of this stuff is on different layers so that it is easy for us to actually have our character sprites go in front of them when they're supposed to be in front of them and behind them when they're supposed to be behind them. So we have a bunch of data that's then overlaid on top of these. Up at the top here, there's a bunch of buttons that you can turn on and off. We can turn the actual graphics on and off. We can turn hotspots on, so you see there's a hotspot on the bed. If you remember in the game, you can click on the bed to rest, and you can click on the fridge here. There's always a loaf of bread sitting in the fridge for you. We have the walk areas, so these are the areas in the level that the character sprites can actually interact with and walk around. That's the boundary. If we turn that off, then we have exit areas. So this is the exit right here. So if the character sprite actually moves into that exit, this exit is defined with logic that says where to go, what level to load to, and where to put the characters when they get there. Moving on, so we have actors. So the first thing you'll notice when I turn on the actors button is that the level has all of the talking heads and all of the character sprites and stuff that are actually going to be used in scenes. So here we have all of our main characters, some of the Junker children, the workbots, the mayor. That stuff is all sitting there and ready, waiting for us to use it in scenes. So it's part of the level. In addition to all of those, we also have other things that we would define as actors, and that seems to include sound effects. These are point sounds. So there's ambient sounds here, and there's point sound, ambient sound of the kettle on the stove, and the actual stove that makes sounds. The circles that are surrounding the sounds that have been placed into this level are sort of a radius. So as you get closer to that sound, it's going to get louder. So that was a pretty cool tool that we added. So that we could have sounds that actually changed as you moved through the environment to give you a sense of the space. So these points here are actually used in pathfinding. Rather than build a very complex pathfinding system where every pixel on the screen was used for pathfinding, our level designers actually went in and they placed all of these predetermined points. And so if the player sprite was pathfinding through the area, would actually use these points as sort of little nexus points to go to if it ever got confused or if it needed to go into a new area. And it just kept the number of, if I understand things correctly, it kept the number of calculations down that was required for our characters to pathfind. The pathfinding worked really well. They could go pretty much, you could be in a gigantic level and click all the way on the other side of the level, and the character would get there. And it wasn't as computationally intensive because we put in all this data to help the characters figure out a quick and easy path to get there. And then finally, we were able to put in lights. These are actually like the sounds with the radiuses around them. These are actually lights. So this right here in the center is an actual light that is supposed to be the fire coming off of the stove. You see this big round circle oval in the center, and you can see where the lights intersect with the walk areas, and you can basically, what happens is when the player sprites or any sprite gets close to that center and starts entering that circle, its entire palette starts to get changed to be the color of that light. And this allowed us to actually have this really cool effect, whereas characters got close to fire, or they got close, or they went behind a blue colored light, that was part of the background. That color, that light would actually start to affect the sprite, which really helped marry our sprites and characters into the levels. It was really pretty cool. We were really really happy to get that working, because it really helped, like the sound, like the point sounds. It really helped get everything situated and feel like it was actually in the level and affected by the light sources in the level. And this affected more than just the colors of the sprites as well. It really affected their shadows. If you remember in the game, the characters have very well-defined shadows that react to these light sources. The shadows are drawn in the correct positions, as if the light is casting the shadow off of the character. If the character moves past the light source, the shadow on the ground changes and shifts and grows and shrinks. It was a very, very cool effect, especially for a 2D game. It added a lot of three-dimensional depth to the game, and I still really think that was a cool effect. And so here's an example of a level that people who play the game should be familiar with. This is Junk City. So in the tool, you can zoom out. You can see, this is a fairly mid-size level. So it's only a couple screens wide by a couple screens tall. So the biggest levels in the game were 10 screens by 10 screens wide. And you can see some of the things that I talked about before. You see these big circles. Those are the sounds. Zooming in, though, let me zoom in a couple levels. So just, turning on off some of the levels, you got the base floor, the foundations of the buildings, backdrops. You've got everything that's on the first floor, on top, everything that's the roof pieces of the first floor, everything that's on the second floor, the railings, third floor. So this is a multi-tiered level. And if I go and I turn on the walk areas, here we go, you can see all of these walk areas, and these are divided up into different layers. So these buttons up here in the upper left-hand corner, I can turn off the top layers so that I'm just looking at everything layers 0, 1, and 2, 0 and 1, and layer 0, everything that's on the ground floor. So even the walk areas are separated by a level system, so that the player characters can actually go up to a second floor, and then they can walk over a bridge, for example, that might cross over a walk area that was actually underneath it on the first floor, and they're no longer interacting with that because the tool tells the game engine that they're now on the second floor or the third floor, for example. So all of that data was set up for each individual level by our level layout artists, our Terra Builders. So just to show you an example of how they might go in to a level and set things up, this level is Grub's workshop. Each one of these things in the background is an object. It's an individual object that can be picked up and moved around. You'll notice that I can put those objects wherever I want. This is not a tile-based system. Every object can be freely placed wherever you want it to go. So if I want the chair over here and I want this bed to be over here, that's where it's going to be. Now each individual object has its own sorting data. So if I click on this chair, for example, you'll see that there is a line that has been set up by the level artist at the bottom of this chair that tells the engine where the sorting point of that chair is. So every individual character, they sort by basically a point that's close to the bottom of their sprite near their feet. That is the imaginary point at which they are sitting on the ground, that character is interacting with the ground. So basically the engine looks at that character's center point, and it looks at this line when the character and the object are interacting with each other. And if the character's center point is below this line, they will sort in front of the chair. Once their center point gets above this line, they start sorting behind the chair. So every chair that's used in the background has that line associated with it. So it doesn't matter how many of these chairs I put in the level or where they are. every object in the level has its own sorting information. So the level layout artist can put this table over here. They might then have to go in and edit the walk areas, because you see that they have the character has the ability to walk everywhere, but they had placed a point where that chair was. The chair used to be over here where that cutout in the walk area was, so that the characters have to walk around the chair. So it's completely up to the level designers to lay everything out. They don't have to work with a grid. They have a grid if they want to. If they want to see an isometric view, or they want to see a grid like this, or they want to see just little points of a grid so that they can get their bearings, but they can pretty much place everything wherever they want. So all of these items in the background have their own sorting information. The characters have their own sorting information. The level layout artist can put these objects wherever they want, on any layer that they want, on any level that they want. Remember, the characters can be on the bottom layer. They can go up a ramp and be on a story above. They can be on a second story, a third story, a fourth story. All of that information was sorted together by the engine to allow the characters to go wherever they needed to go. This was very powerful. We could make very organic looking levels. It really allowed the artists to build very organic environments, allow the characters to move up and down different stories of the backgrounds, and all of the sorting information sort of came from the objects that were in the levels themselves. Moving on, one of the other things that Terra Builder allowed us to do, if we hit in the upper left-hand corner here, there's a little scene icon. It allowed us to build all of these scenes in the game. All of the scenes that happen when you click on something in the background and you see character heads pop up, or characters walk from one place to another and interact with an object, we built those using this. So this is a timeline animation system, and I'm going to play really quick just to get us started. So this is a scene that takes place at the very beginning of the game. It's the first scene when you get to Junker's HQ, and it's a very simple scene. In the upper left-hand corner, you have the window here that's showing where we've set the screen and our actors. And then in the bottom area, we have a timeline. And the timeline includes everything that's going to happen in the scene, every actor or object that appears in the scene. So including the screen, so we can set the screen where we want it to be. So if I can move the screen around, so you can see that, there's a bounding box that shows where the scene's going to be set within the level. And we can use the screen actor at the top here to pan the screen around back and forth. We have Maya, our main character. She's always player 0. And then we have 2 slots for extra characters. She had someone in her party, which of course at the beginning of the game she doesn't, so you don't see anybody here. But we always had to use these to show where these other actors are going to stand. Whoever you had in party position number 1 was going to go to this dot right here at the beginning of the scene. Whoever you had in party position 3 was going to go to this dot that you see on the screen right here. And we have different actors like Maya's head here. That's her talking head. And we have Grub's talking head. That's this actor here. If I click on it, it selects it in the scene. And then we have this right here. Down towards the bottom of the timeline is actually the dialogue. Each one of these bars represents a voice clip. So that's Maya's dialogue, and that's Grub's dialogue. We even have an actor that represents all the text. So this is Maya's text that transliterates what she's saying into the text box that appears at the bottom of the game. And this one over here is Grub's text box that transliterates what he says at the bottom of the game. And you can select them up here. You can select which text is going to go. So we had total control over marrying different text to different audio if we ever needed to do that. And then we have the actual Grub NPC. So this is Grub. If I select the actor down here, it selects him in the level and in the scene. Show you what you're working on. And you can scrub through this timeline to see the scene play back and forth. I'm going to hit play once and we'll watch the scene real quick. It's a short scene, very beginning of the game, when Maya and Grub return to Junk City headquarters.
You should come in and see Uncle. He asked about you today.
Zero hope, Maya. I have to work on runner sensors. Next time. Promise.
So it's a real quick scene. And what this tool allowed us to do is, if you notice, when Maya and Grub are talking, when their talking heads pop up, they are not just gum chewing. They have a little bit of lip syncing that we were able to do, which is very cool. So Maya, if I select Maya's talking head in the scene, and I scrub through it, you can see that she's doing a regular sort of, happy talk, and then she tilts her head. When she tilts her head, it's because on the timeline here, at the bottom, on her actor timeline, the first animation, all the information about the actor that you've chosen is shown up here to the right of the scene. Her first animation that it's playing is her normal talk. And then when we get to about a second into the scene, it switches to this animation, which is her friendly talk. Maya had lots of different talks. She had normal talk, mad talk, excited talk, upset talk, friendly talk. And in addition to that, each character also had individual frames of the mouth movements, of closed mouth, an E sound, an ah sound, an O sound, in different versions for happy talk, mad talk, so that we could actually go in and lip sync a little bit. So Maya switches to her friendly talk here because in the dialogue she's saying something friendly, and it's nice to have the characters emote a little instead of just sitting there and doing the same gumshoe animation. Same thing happens with Grub here. When I scrub through Grub, you can see that if I select him at the first, he's doing his normal talk. Then when he gets to a certain part of his dialogue, he switches to his excited talk, so that it's a little bit different, and it
Work on runner sensors next time. Promise.
And we are also able to go in and put a little pause between, like right here, he's saying next time, pause, promise, pause. So our scene developers were actually able to go in and really lip sync all of this stuff to make the characters feel like they're more alive. And all of these things you can see on the timeline, there's all of these little arrows pointing to different lines on the timeline. That's because these things were interdependent on each other. So Grub's dialogue, his talking head only pops up. This little arrow, you can see where my mouse is, it's over here. This little arrow goes down to Grub's dialogue. So when that dialogue sound starts playing, it causes on the timeline the talking head animation to start playing. And this becomes very easy to see if I actually start moving some of the actors around. This is an example, I'll show you right here, this is an example of Grub as an NPC. He's in his walk animation. That's this one down here at the very bottom of the timeline. And we have selected to have him do his walk, and we have selected to have him not walk in a specific direction, but allow the game engine to choose the direction that he's walking. So if he's walking towards the bottom of the screen, it's going to choose his south facing. If he's walking up towards the top of the screen, it would choose his north facing. But if I wanted to, I could have him walk facing to the north and he'll moonwalk down to the bottom. So if I play the scene now.
Sensors next time. Promise.
So I have complete control as a director of the scene as to what I want him to do. As a matter of fact, if I just pick up this point that he's walking to and I move it over here, now Grub is going to walk over there. Still, I have him facing to the north. Let's instead make it a run and have him run facing to the east for some unknown reason. So that when I play it,
And runner sensors next time. Promise.
He's going to run over there. And you'll notice that when I pick up and move where he's going to go, it adjusts the timeline. The longer it takes for him to get someplace, the more it's going to offset the rest of the scene playing, because things that are going on later in the scene are dependent on him getting to the point where he is going to run to. This was very powerful for us. All we had to do was create interconnectivity between all of the different actors and have them, one actor on the timeline be dependent on another actors on the timeline finishing their action before they start, and pretty much everything would play correctly every time you played it. In fact, when we localized the game to German, what we did was we just replaced all of the dialogue files with German dialogue files, and all the scenes played correctly because the actors and actions that they take in the scene were tied to how long their actual dialogue is. Now, German tends to be longer dialogue files than the English versions, and that could have been a big problem for us, but because we had this system, you just drop the German dialogue files in, and the scenes expand or shrink based on what the new length of those audio files are, which was very cool. Of course, the scene didn't work perfectly. Things were off and timing-wise, and animations were a little bit off and stuff like that, but really all we had to do was go in and tweak those scenes to shorten or lengthen some animations by dragging a couple things on the timeline here or there, and just generally clean it up. to make those scenes work, which was much faster than having to build them from scratch. Of course, we then went into the German version and we re-lip synced it so that the character stopped talking and started talking and paused and did the right vowel frames for the O sound or the E sound, or got mad or got happy or whatever, based on what the German actors had done. So that was very cool.
Komm doch mit rein zu Onkel. Hat heute noch nach dir gefragt.
Keine Chance, Maya. Ich muss an Runners Sensoren arbeiten. Nächstes Mal, versprochen.
So there was a lot of power in this, and it really allowed us to do some very cool stuff. Like just playing around with this now, it blows my mind that we built this in 1997, 1998, when games really didn't have a whole lot of off-the-shelf tools to allow you to build stuff like this without building the tools yourself. We had worked on a game at Viacom New Media, a few of us, on a game called Beavis and Butthead and Virtual Stupidity, and we built a tool very similar to this to do that. Starting over at Valkyrie, we had to recreate the basic concept of that tool from the ground up, and it got even more complex as this game had combat. I can go in here and I can have Grub jump to a point. I can have him start to take out his sword, take out his weapon instead of walking. The other cool thing that is happening here is that you'll notice that Maya is set to actually look towards Grub, so that as he walks out the door, she turns to face him, rather than go in and have the artist set those frames by hand, like, oh, let's have her looking up, then upright, then right, then down right. She's just set in her animation to point to Grub NPC. But she could point to the Maya head, the Grub head. She could point to pretty much any of the actors in the screen, or she could point to the world itself, which is probably a default. So that was a very simple scene. 2 actors, a couple talking heads, very quick. The actual scene that happens after that is a much more complicated scene. This is actually the beginning of the game. That sort of starts to set up the conflict with Tori and somebody smuggling the weapons into Junk City. And the mayor comes with the workbots and everything. This scene is way more complex. Same location, using a lot of the same actors, but look at this timeline. This timeline is just massive because there's just a bunch of things going on in the scene. We have actors for each of the children. We have actors for each of the characters' talking heads. And if I scrub through this, you can see, the characters talking to each other. Uncle walks in. You notice right now that Uncle is actually behind an animation of the fire playing in the backgrounds, because we didn't bother to make the tool really sort sprites very well. The engine was going to do that. The tool doesn't really do it that well. It doesn't sort it with the background stuff. You'll even see the like when Uncle walks in, he walks in front of the steel beam right there. We didn't make it too pretty for the scene directors. Later on, let's see if we keep going through this very long scene with all of these interdependencies. Yeah, the mayor comes in and he talks with the workbots. Let me play a little bit here.
Boy. Mayor, what's the meaning of this?
Search the place. They're hiding in here somewhere.
Good day, Uncle. Good day, Miss Maya. It's a fine day. Yes, the fresh air would do wonders for you, Uncle.
All right, enough. We're not here to eat lunch. We're here to arrest smugglers.
So in this scene, the person who's directed this scene, I don't remember if it was me or if it was somebody else, but they've got all the workbots here. Here's workbot A and workbot B, and you can see all of the points that the character's going to walk to. And as I scrub through the scene, you can see he walks from one point to another. Then he does an animation where he's searching, and then he walks to another location and he does a search animation again, and he walks back towards the door. Again, you can pick up all of these. Now he's going to walk over there and do his search. And of course, the engine's going to face him in the correct direction. If you wanted to have the character walk faster, you can increase the animation speed. It's set to 100%, but you could have him walk, 200%, and he'd walk twice as fast towards something. So we had a lot of options here, but you can see all of these very, very complex interdependencies. And once someone got their hands on this tool and learned how to do it, maybe it's not the prettiest thing in the world, and it can be a little bit complicated to see all of the connections at a glance. But once you knew what you were doing, it was very powerful, and you could do a lot with it.
How are you?
Stay in at night, friend. It's not safe to walk the streets at night. The undead'll get you.
Okay.
So Terra Builder also allowed us to pretty much set up and control all of the NPCs in the game as well, and we did that using the scene tool. So the Terra Builders, the level layouts and level layout artists and animators could go in and place characters into the background and determine what they were going to do with the scene system. So let me zoom in on this guy. So this is a NPC that walks around the world, and the level artist was able to go in and use the timeline to determine where this guy's going to walk around and what he's going to do. So he walks over to the trash cans and he fiddles with them. This animation would play, could be hooked up to the game logic so that he might do that animation. Then he might do, where is this one? Oh, here, he's down here. So the game engine might randomly have him do this one where he walks over and looks in the window, and then walks over here and looks in that window. So all this stuff was able to be set up by the artist without ever having to get programmer help. But wait, there's more. So not only did this tool allow us to set up all of the stuff that I've shown you, it also allowed us to set up the enemies, their walk paths, where the combats would take place, where NPCs would walk around, and it also allowed us to set up logic for the game. So we were able to use this tool to define logic variables that would that I could create and input into the tool that would store various states of the game. So, for example, are you in chapter 2 or not? Are you in chapter 3 or not? Have you picked up the generator or not? Have you killed this boss or not? And then I was able to use those variables to actually script the logic of the game without having to have any programming experience. And the way that we did that, this is the Junker HQ again. If I click the upper left-hand corner here, there's a little button called AI. And if I click that AI button, it goes to what is essentially a visual logic scripter. This is a tool that I developed with the programmer of the Terra Builder after we played a game on the PS1, the PlayStation 1, called Carnage Heart, which was this robot simulation game where you would make your little combat robots and you would use a visual flowchart that was basically a grid to go in and program the artificial intelligence for your robots. And we had quite a bit of fun making robots and pitting them against each other in the arena. Well, we thought, why not take that basic concept and turn it into a simple visual flowchart that anybody can use, even if they don't have any programming experience. We could put this into the hands of the artists. We could put this into the hands of me and script most of the logic for the game without having to have programmers help us with it. So using this tool, this is a grid. It starts in the upper left-hand corner, and each spot on the grid represents basically a program command. So when it first comes in to the upper left-hand corner, it's basically asking if the first scene of the game has been played or not. So the first time that the game comes to Junk City headquarters, it asks, has the game begun or not? Has the first scene of the game played or not? If the answer is no, it actually plays the opening movie of the game. And then it plays that scene, Start Game with Grub, that I showed you in the beginning of this video, where Grub says he can't stay, he has to head off. And then it plays this scene, the next one, that much more complicated scene that I was showing you the timeline of, where Maya comes in and she talks to Tori and Uncle, and the mayor comes in with the robots, and they're looking for the smuggler and all that. And then once it does that, it actually changes the variable to a different from 0 to 1 to basically let the game know to remember, I have played the opening scene, don't play it again. And then the logic continues through the flowchart all the way over here, where it changes a couple more variables, checks another variable, and either dumps out and ends or actually plays another scene. This other scene that it might play at the end of the logic here only plays if Maya is returning to Junk City after having been away, which means we're in a much later chapter. So there's this whole scene where she comes back, and there's, we made a special scene because that was a momentous occasion. She's come back. She's been away on adventures for a while. And if you come back to this level later, it checks that first variable that it changed, and now the game knows you've seen the first scene of the game. We don't need to play it anymore. So instead of going down the chart, it goes to the right, and then it checks another variable, and depending on that variable, it will hide some of the actors, these little Hatman symbols. That's a long story, don't get me started. These little symbols called Hatman represent actors in the game, and it would hide the children. Because we don't want to see them anywhere. They were only part of that opening scene. So this was a very powerful tool, and this little grid in the bottom left-hand corner has all of these programmer art icons that represent different things that the scripters using this logic tool could use to actually program the game. Everything from starting a dialogue sequence where the player gets to choose who's going to talk, changing a key item, all those items that go into your inventory that are more like adventure game items that you can take out and use as keys to affect the storyline. It can exit out, it can play a movie, it can play a scene, it can start a combat, it can change a variable, it can give you money, it can affect actors, it can affect walk areas. We actually had a thing here to roll a die to get a random result, different kinds of random results. Check a skill, allow to run an event where the player might steal from a shop. So using this tool, we were able to hand this tool off to artists that I don't think had any experience with programming, and those a couple of the artists that were working on the backgrounds, they used this tool to program pretty much all of the basic key door logic that's in the game, because those were very simple scripts that you didn't have to know anything about the story. You just had to know, has the player, when they interact with this door, do they have the key? If they do, they can open the door. If they don't, they can't open the door. And then I was able to take this tool and string all of that stuff together into the larger storyline, where the script as I wrote it already had all of these variables set up. So all I had to do was go in and script the logic using this visual editor. And I had a little bit of programming experience, programming in BASIC, back in high school and stuff like that. But I'm not a programmer, and I was able to program, set up the logic for pretty much all of the main storyline. Only time I needed a programmer to come in and help me with stuff is when it touched on an element that we weren't able to allow the tool to affect. I'm happy to say that I only made one major mistake that we had to patch out, where you were actually able to skip an entire chapter of the game if you did things in an order that I hadn't quite thought that you would be able to do them. But other than patching that one major snafu, I think the logic for the game was very solid. And it was all done with this tool. Now, we also use Terra Builder to script all of the combat sequences in the game, which means that we set up all of the enemy statistics, player statistics, enemy AI, combat skills, everything. And we did that by using a combination of our logic grids and our scene system. So if I go ahead and I have here a list of all of the enemies that are defined in the game, I'm going to open up Alisa, Princess Alisa, the chosen emperor's daughter, who you wind up fighting partway through the game. Spoiler alert. So right away, her character has all of this information that comes up. It's mostly defining some of her basic statistics, her base stats, what different animation modules, what frames she's supposed to use. It points to different animation modules of frames for the characters. It defines some of her collision data, how far she can see if she was walking around on a level. Would she be able to see the players when they get half a screen away from her, a quarter of a screen away from her? Whether or not she has any attack bonuses, for example, is she more susceptible to fire, earth, air, water attacks, stuff like that, her run speeds, things like that. Basic data. And then we have all of her combat skills. So all of her combat skills are here. She has a boomerang that she throws a boomerang. She throws curse. She throws a barrier spell. And all of those individual skills have their own statistics all set up here. Like how much core does it cost? Is it an earth element, an air element? Is it something she can do on a weak endurance bar, a medium endurance bar, a strong endurance bar? Whether the game effects, like the boomerang, for example, does physical damage, that sort of stuff. And we would be able to use the scene system to actually go ahead and set up those animations so that when she actually does her boomerang throw, she will play this scene, which is... And so the scripter for this character, basically has her set up as her sprite, and the animation that she's going to go through. This X in the center of the screen is representing what her target's going to be. So it doesn't matter where her target is going to be, she's going to do this animation. And because the game engine is being told in the upper right hand corner to not give it a direction, it will do it when it's played back in the engine in any direction that the engine needs it to. So while we're seeing it here where she's throwing down to the left, if the character that she was attacking was up to the right, she would throw it up to the right instead. It would play her throw animation, but the engine would choose a different angle to show her throwing it from. And so let's see, she also has a killed animation, so this is the animation that she plays when she dies. And so all of these different things work together with the AI system. Uses the same scripting grid that we used for basically all the logic in the game, and she has different events that this character will call to when she's involved in combat. So this is an event that she actually plays when she enters combat, and it's going to do all of these things that are in the grid, and basically she's going to do a bunch of skills. She's going to throw a barrier, she's going to throw barrier on all, she's going to do some boomerang stuff, she's going to basically cast a bunch of spells at the beginning of the combat, because she's a boss. But when her endurance bar, just like the player characters who have to wait until their endurance bar gets up to either a weak bar, a medium bar, or a strong bar before they can activate and do an attack, the enemies have the same limitations. So she has an event that happens. This is her logic grid that would be referenced when she decides to do an attack on her weak endurance bar. And so right away, the first thing it does is it actually rolls a die. She has a 33% chance out of 100 of actually doing something on a weak. If she rolls the die and doesn't and gets the wrong result, she's just going to ignore all this stuff and wait till her bar gets up to a medium, and then check the medium to see if she's going to do something. And of course, if it gets all the way up to a strong and she still hasn't done something, then she'll do something. So you can see on this logic grid, a character who is going to do something in combat is going to be checking die rolls for so that there's a little bit of randomness to what they're going to do, so it's not the same every time. Some of these event queries are actually checking variables. These are variables that are actually looking, for example, at whether or not any of the enemies that are with her actually have a barrier on. And if they don't, she's going to there's a chance that she'll cast barrier on them. The enemies would be able to do things like check to see which character in your party has the lowest hit points. Maybe an enemy is more likely to attack a character who's almost dead, that sort of stuff. So let's see, on her endurance strong, a completely different grid that determines, whether or not it's going to do a 50-50 chance right here, and it's either going to go down and do, these skills down here, or it's going to go to the right and do these skills over here. So basically we were able to take the scene system, marry it to the enemy AI system, and completely determine how those characters were going to react when you fought them. And we didn't have to have a programmer involved at all, which was pretty awesome. So thanks for going on this tour of Terra Builder with me. It's been a blast to fire this tool up after 21 years and really remember everything that's in there that it does. I had to relearn how to use the tool. I'm still finding stuff that I've completely forgot that the tool could do because we stuffed it with so many things to, like I said at the beginning of this video, to allow a very small team on a very small budget make the biggest, most expansive RPG that we could. So it's been a really fun time. I hope you enjoyed it. If you're interested in learning more about the 20th anniversary of Septerra Core and behind-the-scenes stories about how the game was made and the people that worked on it, check out my website. There's a series of articles there. It's twilighttangents.com, and I hope you come and check it out.